we've got balancing reasoning, the reasoning to do with balancing. Let's consider the situation we have here. We have a set of scales or a balance, and it looks like the beam here is horizontal, so that would mean the mass on the left side equals the mass on the right side. And we've got a mass of 7 on the left, and we've got two identical objects in blue there, the rectangular shape. We've got a 15 on the right, and they create balance. So what we essentially have is two things that are equal. We have 7, and we have, look at the color right, two rectangles, and they're added together, and they equal, on the right, 15. How do we work out the mass of the unknown blue rectangles? Well, let's have a look. I guess one way of doing it is just guess and check, but guess and check is rarely very efficient. So what else can we do? What if we took 7 units of mass, so let's say whatever they are, kilograms, and what if we took that off? That wouldn't be balanced anymore. What do we have to do to balance it? Well, we have to take 7 off that side as well. So if that was 15, if we take 7 off, we've now got 8. So we have 2 identical blocks equals 8 units. Well, we can reason that directly. If they're identical, 2 of something makes 8. Well, we know 2 times 4. So the answer is each of those is equal to 4. So we can write our answer in here. 1 rectangular block equals 4. So that's our answer. Did you notice that we did the same action to both sides? Did you notice that? And we can quickly check our answer. Let's see. We originally had a 7 here. We had 7, and we had 2 lots of 4, and we had 15 over there originally. So does that work? Order of operations, 4 times 2 is 8, 8 plus 7 is 15. Yes, it works. Let's try another one. This time around we have hanging balances. So we've got the middle, and then we've got a left side, and we've got a right side. Okay, on the right side we've got a grey rectangle and 11. On the left side we've got a balance on one side of a balance. So here it looks like these two are in balance as well. So we've got an inner balance and an outer balance. So we've got two things that are unknown. We don't know what the grey rectangle is. We don't know what each of the triangles are valued at. We've got two things to find out. So this one's a bit more complicated. How do we do it? Well, what we start to do is look at the little balance first. So the little balance says a triangle plus 6 must equal 2 triangles. Well, what we can do, what we can do is subtract the same from both sides. What I have in mind is to subtract one blue triangle from both sides. Let's have a look. So if we subtract one blue triangle, we would just have 6. If we subtract one blue triangle from the right side, we would just have one triangle. So a triangle is worth 6. That means the left hand side, in maths we write LHS for left hand side, is a triangle plus 6, which is 6 plus 6, and the right hand triangle is 2 times 6, 12 equals 12. That's right. And altogether that's 12 plus 12, and we have 24. So we have 24 on the left, so we must have 24 on the right hand side. So what we have is basically an 11 mass plus a grey square or rectangle, whatever it is, and that equals the 24 that we said on the left hand side. So 11 plus something is 24. If we take 11 off, we get the, if we take the mass of 11 off, we get the rectangle by itself. Let's do that. But wait on, that would cause this thing to be unbalanced. The left side would be heavier, so we have to take 11 off the 24 as well. And that would be 13. Pen's not writing. So 24 take 11 is 13. We took 11 off because we took 11 off the left side, so we take 11 off the right side of this little number sentence here. So that means we know that a triangle is worth 6, a grey square or grey rectangle is worth 13. We can check that to see if left equals right. We've got 13 plus 11 is 24. We've got, as we said before, we've got 12 here, and we've got 12 there. That's 24 as well. So yes, it works. In class, you're going to also play with an app on a website, and it gives you other ways of playing around with balancing. And here's a quick example. I'm not going to do this one for you, but I'm just going to show you. We have negative 4x plus 1 equals x minus 4. It's a little bit more abstract because it's using x, whereas the other one used concrete objects, but it's worked the same way. Just would like to show you that you've got a choice between x block like this. You've got a choice between a constant 1 like that one. You've got balloons. The balloons pull upwards, okay? So that one there, alright. And you've got constant balloons which pull up by 1, and so on. You can keep adding them there. Alright, this also has the ability for you to go onto a new problem. Okay, and as an extension I'm going to get people to create their own problems, but it'll only let you create a problem if it has a solution. So you've got to create something that's going to work first of all.